Hello, in this video tutorial I will show you how you create a classifier to check the graphite areas on the piston. In this case we have wet graphite, not dry. This is not important, but it's better. And the next we have a good contrast from the background of the piston to the graphite. This is necessary. So first what I do, I rotate the piston a little bit so I have all two graphite areas good in the picture. Now I have all two areas separately. Okay, so next I'm choosing the classifier, piston graphite classifier, and here I'm choosing new classifier. Then I have two options. The first option is standard, two graphite areas and pinhole reference, and the next is a user-defined reference position. This means maybe you want to create this classifier by a reference of the oil gap here or whatever, but normally we're using the pinhole reference standard. I use it, okay. The next two options, you want to teach two graphite areas, piston norm, or maybe you want only one graphite area to teach in the headland, for example. In this case, I have two graphite areas, piston norm, okay. Please click now with the mouse to the center of both graphite areas, okay. I click like very similar to the center, and here. And then you give him a name, for example, Graphit Check. Okay. And then comes a message, please use to adjust this classifier optimal graphite area piston. All graphite areas are in the middle of tolerances. This means please do not use here for adjust and create this classifier. Do not use areas who are not perfectly by position on the piston. Okay. Now the program filled out the graphite by himself with blue, and you can see it looks good with the standard settings 10, 10, 10. And here comes information. Please check there are all graphite areas will be filled. Small missings will be allowed if they will be good. This means small mistakes here. Change the RGB threshold while not all areas will be filled. These adjustments will take a little bit time. Okay, I will not have this message again. Here you have three tolerances, RGB, or three channels, and here you can adjust all three together. If you go down here, the tolerance comes smaller, and I go smaller until the graphite is not completely filled, like this. Here I remember me 4. Now I'm going with the tolerance higher. I go here to 20. I'm going now higher until the graphite is leaving out the area. Look now. My filling is leaving, and one tolerance step more, and you can see so now my tolerance is too high. So I remember 4. Now here I have 26. Minus 4 is 22, and the half is 11. So 11 is the optimal position for beginning to adjust this classifier. Okay, the next is accept current settings. Yes. And if the area is not complete filled, then please enlarge the blob filter. Okay. Now I'm going to the work mode and go to properties and tolerances. And here I have a drawing. The first is my blob filter tolerance in millimeters. This means very small blobs will be filled also. And the normal tolerance is in this case 0.478. This is standard, this is okay. Area mass tolerance in percent, this means every area is filled by pixels, and the mass of these pixels are 100%. And we will have a tolerance at 3% of this mass of the pixels. This means maybe here is a little bit is missing inside graphite. Then with this percent you can adjust the sensitivity of the classifier. 3% is normal. Then we have two tolerances by width and by height. In this case 1.5 millimeter. This is also normally standard. Then graphite area position check is true, and the position tolerance, in this case by this piston we have 2 millimeter tolerance. Then the graphite area contour check is false, we will check it, all two. And the graphite contour tolerance is 1.2 millimeters, and we have here 1.5 millimeters. Accepted, and that's all. Here you can test start it. Okay, and what you can see here is the green around, this is my tolerance of the contour. The blue line shows the nominal position of the graphite. And here we have five results. The mass check, in this case, is a difference is 0%, because this is our first piston, we teach him. Then the width check, height check, then the area position check, and the contour check. 5 checks for every piston. Now I move this classifier to the program. Add object, and my classifier is here. Accept it, and show results in display. And start program again. Okay, I'm loading another good part. It's okay. And you can see here, it's no matter if the graphite going in the top out the picture and coming in the bottom in. This is no problem for this functions. Okay, I'm checking another good part. Okay, now I'm looking for bad parts. In this case, my graphite is, the position is not correct. It's too much in the bottom of the skirt. Start check again. And look, in this case, the graphite is leaving out. This is okay. I'm clear the picture. I'll show you where. Look, in this position, the graphite goes outside. Then we have the next example. Here we have a graphite is too much in the top of the piston. And here we have also graphite. So he kicked this piston off also. Okay, looking for another damage. This is clear, this is no problem. Okay. This is also not good. For example, I'm loading a good part again. Now I will show you, for example, I make a little damage by myself. With this tool here, with a pipette, I get this color. And here I'm creating a rectangle. Maybe like this. Test it again. And you can see here he found the bed, and we have a contour check failed in this case. The mass is also okay. It's a difference only by 0.484%. Okay, that's all.